Hello, welcome to End-Door N-Gauge Model Railway. I'm Jonathan. I was having a think about what to do with terrain to cover these wires, and concluded the wires needed to go underboard to make way. There were some things under the railway that needed to go to the attic to make room for the wires, but to get those out the way I needed to get the railway's base out of the way. I'd been careful with previous wiring changes to make sure that it would be easy to lift the door from the frame, from a wiring perspective, so I just needed to undo 2 clips to disconnect the point motor switches. I hadn't previously done anything about making it possible to prop the door upright on the frame. By chance it did just about balance, but that didn't seem very stable. I added some clamps in front of it. I figured they'd be enough to stop a gentle wobble from toppling the door forward, and some clamps at the top to stop the terrain from being crushed if the door toppled backwards. Once I'd removed those mats and bits of spare carpet underlay, I laid the door back down with a big overhang to give me easy access underneath. I used some spare wood offcuts to form a little makeshift bridge to stop some cables getting crushed. Drilling holes for cables was easy. Once again, I was pleased that I'd used screw connections for the wires. It made it very easy to disconnect them. All of the wires attached to track happened to be long enough to go through the door and have enough left to work with on the other side. Actually getting the wires to go through the door can be tricky though. The inside of the door is basically cardboard. The drill goes through easily enough, but some of the cardboard usually springs back a bit into the hole afterwards, and that pushes wires off course when I try to feed them through. To defeat this, I use some heat shrink tubing, which I poke through on a screwdriver. Once all of the wires had been poked through holes, I put the door back onto its side, closer to the edge of the frame, to connect everything on the door's underside. This was a lot easier than the rewiring I did a few weeks ago, where I left the door in its usual position, but I had to be very careful not to press with much pressure at the times when I couldn't steady the door with one hand. The clamps did stop it from toppling over a few times, but they definitely weren't going to stop it if I pushed it at all hard. I didn't have to give complex thought to what needed to connect to what. I simply needed all red wires to connect to each other and all black wires to connect to each other. Once that was done and the door laid flat again, I tested that power was being delivered to the siding track by attaching a multimeter and touching a 9-volt battery in several places. I decided not to think about this in great detail. I was aware that some of the rails can get electricity through fishplate connections, but I think it proves the wiring connections to most of the rails on these sidings, because they have insulated fishplate connections to the points. So the only place they can get electricity from is the wires that have gone under the board. Over the last few months I've found that my point switches can occasionally stop working, so with the layout clear I decided to investigate. I suspected loose connections, and there were indeed some very loose spade connectors. I disconnected them and squeezed them a bit with some pliers, which seemed to sort them out. All of the siding points switched okay after that. But only one of the mainline crossover points was throwing. They should both work together. I found one connection that was a little bit loose, so I tightened that up. Ultimately, it seems that this pair of points only works if the capacitor discharge unit has time to fully charge. Here I demonstrate successful switching with a bit of a gap between switch throws, then show that only one of the points changes if I only have a small gap between throws. I don't know why it's always the point on the inner loop that works. The point motors are connected in parallel, and the capacitor discharge unit says it's good for 6 of these point motors. Both point motors have to operate a microswitch too, so I experimented with holding the switch back on the problematic motor, and with that done the points changed more reliably. So it seems that with the extra resistance of the microswitch, the point motor just needs a decent punch of power. With wires out of the way and point switches fixed, it was time to get back to scenic work. First things first, this area of bad paper mache had to go. I'd noticed that the existing parts of plaster terrain had separated from the steel mesh beneath it, so this got me thinking about removable terrain. I wondered if I could use the mesh as a temporary support for the plaster cloth and remove it after the plaster had set. To that end, I decided not to nail the next bit of aluminium mesh in place. If this technique works, then I'll be able to reuse bits of mesh to save money. With some protective plastic in place over point motors, I applied the plaster cloth. A more curved area of terrain proved too tricky for loose mesh. I had to nail and staple it in place to stop it springing out of shape. With the fiddling to get the meshes to link, the rail paper mache started to detach a bit from its neighbouring plaster, so I decided to replace the paper mache with plaster cloth in this area too. I'm pleased to be making progress with the terrain, but it's been a while now since I've run any trains, so I might pause a bit on CNX, give the track a good clean, and get back to running some trains for a bit. That's all for now. Bye bye.